what you interact with. Yeah, I also served on the board for a while, and my heavens, there were former members of parliament and so on that were on there. It was really spectacular. So anyway, there we go. Let's go to the next slide. Yep. There you go. Okay, here's a quick sketch of what we're going to talk about, focusing on grade crossings, which are obviously the most common intersection that the public has with our industry. And it's not always a happy one in terms of irritation or risk. So we'll talk a little bit about it. You'll see that there's a number of ideas here, and there's also some happy opportunities for improvement. So we'll go to the next slide. And there's loads and loads of engineering involved. This is from the Department of Transportation's guidebook on crossings. I mean, everybody's seen one of these things, but just to see all of the specific parts of it there, it's not an accident that these things look the way they do and flash the way they do and so on, and that they're a certain distance from the rail and the gates are a certain distance long and all that kind of stuff. But there's a lot of challenges too. So click the thing again, Andrew. I wanted to find an example of a high angle crossing, and unfortunately I couldn't find one from the States. This is one in Europe, but stop for a moment and think about the truck driver's view of a train approaching from the direction that we're facing, so in other words, behind us. Now, happily, I assume this is a active crossing because it looks like I can see a gate in the distance above the first car there. But, these are sort of the challenges that we're faced with. The railways, in many cases, were there first, and the towns sprung up around them. And there are conflicts at times. I mean, we hear a lot about blocked crossings here in the United States, and we hear about long trains, and we hear about the irritation caused by the horns, which are really a safety measure. In the state of Florida, there's one railroad that operates only in the state of Florida. And so the state of Florida mandated that they not blow the horns on their locomotives from 10 o'clock in the evening until something like 5 or 6 in the morning. They paralleled another railroad, CSX, which is not regulated by the Florida people because it's an intrastate railroad. The dramatic change in the number of accidents at the crossings where the horn was not blown was so compelling that the Federal Railroad Administration had to step in and stop that. So irritating as they are effective. But there are ways to eliminate the horns with things called quiet zones, which require a lot of interaction with the cities and so forth. So, well, let's just keep going. The crossings are certainly, next slide, Andrew. Crossings are definitely our highest source of risk. You can see here that if you look at all the fatalities last year in the industry, crossings were the second largest at 234 fatalities, or over a quarter of them all. Somebody's got some crosstalk going on right now. Please check that you're on mute. I don't know if there's a way you can put them on mute. Oh, looks like
I'm going to see if I can work out where that's coming from.
Yeah, it's stopped now. So we're fine. Oh, now it's back. Well, I'll just keep going. We're not going to talk about trespasses today. You can see that is the highest source of risk and is a major challenge for us. A lot of effort being expended to that. Let's go to the next slide. This is one that I swiped from the Federal Railroad Administration, and it just illustrates how many different fingers touch a crossing. This happens to be near Denver. The red box there is a gasoline truck that just came out of a storage facility below it in the image right there. And of course, the Federal Motor Carrier Administration regulates trucking. Then you can see that there are various crossings there that are the Federal Highway Administration. I mean, these are crosswalks, crossings. The blue box there is a Federal Railroad Administration regulated commuter railroad operation. Right adjacent to it is a light rail, which is regulated by the Federal Transit Administration. And then, of course, there's a couple of vehicles in the green box, which are the National Highway Traffic and Safety Administration. My point being is that all of these different people have a role to play in crossings, but the biggest role is the local road authority. They are the ones that make a decision about whether or not to add signals to the crossing, whether or not to close the crossing and put in a bridge or something like that. So it's not a simple matter when you have so many different rules and participants in the equation. And let me just stop for a moment and say I'm covering an awful lot of things relatively quickly, so please don't hesitate if you've got there's a chat here. Let me see if that's a question really quick. No, it's not. Just thank you. Okay, next slide, Andrew. Our friends at Michigan Tech University up in Houghton, that's the Upper Peninsula, which is full of snow. And Pasi Latila, a friend of ours, is from Finland, so he's perfectly used to it there. But he's done some studies. Pasi's program is heavily sponsored by CN, so he does a lot of railroad engineering work up there. And, it's just kind of, we won't spend a lot of time on this eye chart, but you can see on the far left there, the different types of activities that were occurring at the time of the crash, including not stopping or going around the gate, which is the most frustrating one of all. And then on the right, you can see there's different types of, approaches to preventing the crossings and so forth. You'll be able to see this later when it's posted on the website, so I won't spend a lot of time on it right now. But let's go to the next slide. This shows some recent FRA safety data. You can see that fatalities happily have gone down for the most part. That little uptick for 1 year, I don't know that we can draw a lot of conclusions about that. Anecdotally, we've heard that during COVID, people were becoming more reckless on the highways. Maybe there were fewer vehicles or something, I don't remember. But, what's interesting, though, is that, in 2019, there were more vehicles registered in the United States than ever in history. I assume that might have dropped off with COVID. But, so the potential exposure at crossings has never been higher in terms of the volume of highway traffic. And of course, there's plenty of trains operating, but the record's pretty good. On the right, what is frustrating is you'll notice that so many of these things happen at crossings that have signals at them already. That's not completely surprising because decisions about whether to put a signal, a flashing light, a bell, and a gate in have to do with risk. You're not going to put one of those things on a dirt road where there's only occasional traffic. You put them where there's higher volumes or the angles are bad, like that picture I showed earlier, or maybe there's school buses or big commercial vehicles or something like that. But nonetheless, you can see that, 73% of fatalities occurred at crossings that have the gates. And, you can see on the left part of that chart, the population of different types, like passive crossings, that's where there's just a wooden sign, are by and far the most common. But you can see in terms of fatalities, not nearly as much representative as what you would expect. And I can see the footnote down there. I must have messed that up. It's green and hard to read. But the important thing is that this data is supplied by the federal government based on reports that are submitted by us. So we'll go to the next slide. And this data isn't quite as up to date. Canada has a little bit of a different reporting regimen. So I suspect I could have come up with some more recent data, but it's representative. You can see once again, automated crossings, which to me is gates and so on, 48% of the fatalities. One last thing I'll say, and then I'll hand this over to Andrew, is that some of this has to do with what's going on around the crossing. For example, building a subdivision of homes right next to a crossing, across the crossing, there's a shopping center or something like that that generates more traffic. In Canada, they've done something wonderful called proximity guidelines. Some of you have heard me talk about this in the past, but guidance from municipal planners who clearly don't think much about railroads when they're making their plans, like, well, we've got this wonderful field here, let's put a new school here. And by the way, there's a track there and the home's on the other side of the crossing, which means that kids are going to be walking across the tracks every day. People don't think about that very much. And so this document was created by the Railway Association of Canada and the federal, Federal Canadian, I can't remember, FCM, Federal Municipalities of Canada or something. It's very easy to find on the internet, though. You can just type in RAC, which is Railway Association of Canada, proximity guidelines, RAC proximity guidelines. It's maybe 7-8 years old now, but is a very useful tool and something that I've frequently mentioned here in the States. Thank you, Federation of Canadian Municipalities. Thank you for that, Chuck. If if you deal in planning issues, it's a good reference, even if it's not something directly related to what you're working on. So I encourage you to take a look at it. So with that, I'll be quiet and go on mute so I don't make noise. And Andrew, take it away.
Okay, well, thank you very much, Jeff. And I think the way that we map this out is that Jeff would kind of give us the big picture in terms of, you know, what is a grade crossing, and kind of, you know, the fact that, yeah, grade crossing safety is an issue. It is something which is taking the minds of lots of people, and I think the key thing to say is it's not just a railroad issue. This is as much a highway issue, public planning issue. It affects so many people, so many organizations and stakeholders. Now, what I'm going to talk about now is how technology, as I put there, maybe is coming to the rescue in terms of helping us kind of improve safety at grade crossings. Now, I am going to try and avoid using too many acronyms here. I know we're experts at that in the technology industry. The title here includes two acronyms already, so or abbreviations. So AI is artificial intelligence. ML is machine learning. They are fairly similar. They're probably terms everybody has heard of. And this kind of is new technology. So this is something which really has only been available over the last maybe 5+ years. And essentially, this is kind of having more computer brain work when actually doing the analysis. And why is this important when we're looking at the topic of safety and grade crossings? Well, the reason why it's important is that what tends to be missing to enable better policy and better mitigation actions is actual knowledge, it's data. As Jeff mentioned, the data, the statistics that are produced have been compiled by the AAR, by the various rail operators, and that's kind of consolidated together, and the FRA provides that. But in terms of data around how many times is there not an incident, but there nearly was, so near misses, or where there's not even near miss, but there's some form of trespass or high risk behavior taking place. And we've never really had the opportunity of actually understanding all of these different kind of data sets or data points. We tend to be reactive. We're reactive to after there has been an incident, after there has been an accident. So some research on this suggests that there are something like 19 or 20 kind of near miss incidents before there is actually then an actual accident causing injury or fatality, or just a vehicle collision. So this is kind of the premise of where I'm coming from about the use of technology, because artificial intelligence and machine learning is actually provides a really powerful tool to improve the data, to improve the knowledge about what is happening, so we can do something about it to improve safety. Now, the next few slides I have shamelessly borrowed from various organizations. So the FRA and a couple of other organizations you can see there on the right-hand side. I've taken this from presentations that they produce or they've made at some public conferences recently. Now, as I mentioned previously, the problem really is that we're not getting the data. And why is that? Primarily because although cameras have been around a long time, we've been able to record information from cameras a long time. The video recording, DVR kind of capability. But hours and hours of footage where there's maybe an incident that takes place and it lasts for 5 seconds, during, say, a 24-hour period. Actually, finding that is like finding a needle in a haystack. If it's bits and bytes on a spreadsheet, it's easy to find things. If it's audio visual data, it is not. That can't be broken down into kind of code to actually then identify risks, not least because every occasion will be different. So artificial intelligence and kind of machine learning, the ability to do kind of this deep analysis of images has really kind of been a breakthrough technology over the last few years. And that is something that the FRA has kind of been putting a lot of money towards research to help improve safety at grade crossings. And I'm going to give some examples from different initiatives that are underway to kind of give an idea of what that means. So the first one is from something which Rutgers University is doing, a long track record of working on railroad safety initiatives. And I chose 3 images here. The one there on the left-hand side, where you can see different colored lines and boxes, that is artificial intelligence working in practice. And the concept is that it needs to be able to recognize specific objects. It needs to recognize cars, as opposed to pieces of trash that might be blowing around, or other kind of static or moving objects which are not going to be of relevance and not going to be of interest. So identify cars or identify people. There's a picture there on the bottom left where it kind of is identified that, yes, they are people. It also kind of identifies equipment. So we can see in here in green, the green boxes is the signal lights and the barriers which would be in action. And then also it needs to be able to have a spatial understanding. It's no good if it does all of this and it's actually, you know, doing it on a piece of road where there is no rail crossing. So it has the ability to look at the line. And as you can see on the larger picture, the right-hand side, it's kind of needs to be not just identifying where that rail crossing is, but also the fact that there are a lot of different components, you know. There's the real kind of danger zone, which would be a trespass when signals are kind of live, which is in red. Then you have, which is kind of in an orange color, the area which also is trespass. That is private property where there should not be people or cars on there. And then there is the street and the sidewalk, which of course is not trespassing, and that is where people and cars should be when there is signals going on. So if people are in the right place or vehicles are in the right place when there is the crossing lights are flashing, we don't want to be highlighting that this is an issue. Actually, that is a good thing. So hopefully just by me explaining this kind of just outlines the kind of complexity that these computer models need to be able to kind of assess. And this is where the term machine learning comes in, because it's done by doing hundreds of thousands of cases, and it slowly learns, and it kind of is taught which ones are valid and which ones are not. So the term false positive, I'm sure everybody's heard of. It's kind of avoiding those ones where it picks up that, hey, this is an issue, this is a person, they're on the line, but actually they should be on the line. So it's kind of recognized, so it stops giving us alerts when it shouldn't have an alert. Move on to the next slide here. So this technology is still really in its infancy, but the good news is it is getting smarter. As cases go by, more machine learning is happening, and that is being developed. And the FRA have a terrific tool, and it's called the computer vision tool. It's available on their website. And essentially, anybody that is recording footage from a grade crossing can actually submit that to the tool. So you submit what, I don't know what their limits are, maybe 24 hours or 48 hours of data, and it will like run through it, and it will kind of undertake this kind of exception analysis, and it will identify, as you can see on here, where there is activity which needs to be reported, which is actually a positive kind of trespass or high risk or danger activity. Here it's because somebody is crossing where it's actually not a crossing point. The greens are kind of identifying these are subjects of interest because they're people and they're vehicles, but there's nothing wrong with what they're doing. They are kind of accepted. And so why is the FRA doing this? Why are people like Rutgers and lots of other institutes actually doing all this work? Well, it's obviously because we need to collect as much data as possible. And the more information that we have about kind of where things happen, what time of day they happen, enables you to kind of then work out, well, this is some of the mitigating action. This is where investment needs to take place in order to try and reduce the risks. So this is an example of kind of where we're trying to get to. And again, this is something from Rutgers. It's a single grade crossing in New Jersey, where they have hours and hours of, many days, as you can see there, the 3 million car passes have been kind of collected. And the idea is to kind of, identify when the problems are happening and the type of issues that are happening. Is it vehicle? Is it people? Is it a particular type of vehicle, such as trucks or buses? All of this is vital information, as well as the time of day, the day of the week. Now, there is impacts here for everybody, for operators to actually kind of, I think even make their own engineers, that's the train drivers, operators aware, through to the local authorities in terms of looking at, where, how they're generating the traffic, where the other signals are. Sometimes grade crossing paths are a kind of a shortcut on a different route. They're actually maybe divert traffic that way for a particular reason. All of these things can actually add to kind of risks. And if it's known to be a high risk area, then that's worth knowing. But I think the other thing as well is, it aids understanding of where the problems are. There is, however, a bit of a challenge here, or a limitation. And that is that everything I've spoken about so far has related to a single static location. So you have a grade crossing, you put up a number of cameras, and you're able to get all of the kind of the coverage. But we have tens of thousands of grade crossings around the country. That is a lot of cameras. We also, that's probably just the kind of the active ones, or the ones where there's been incidents. Across the nation, whether they're just pedestrian or farm, or kind of protected or unprotected crossings, it's a significant number. The investment of trying to put cameras and then actually collecting all that data from the cameras and then running that through AI processors to try and understand heat maps is unrealistic. We also kind of obviously only looking at grade crossings. The rail network is larger than that, and that's something that I'll also touch on. So one of the other examples of things that people are looking at is actually kind of looking at, okay, well, how can we get more, bang for our buck? How can we cover more crossings, maybe with the investment in cameras? And one example is something that the FRA again have invested in, have funded, is a project by Wi-Tronix. Now, full disclosure here, I work for Wi-Tronix, so I do know a little bit about this particular project. And it has been unique. It's something which is kind of going to be released very shortly. And the idea here is to look at not necessarily the trespass of vehicles and people, but it's actually the safety aspect of making sure equipment is working correctly. So are the barriers kind of activated? Are the lights flashing? Is there anything missing that should be there? Is the audio, can you hear that from the alarms? And what Wi-Tronix has done is kind of develop this artificial intelligence capability from cameras which are fitted in the locomotive. So they forward-facing cameras from the locomotive that are continuously taking pictures. So as you can imagine, as that train runs, it goes through hundreds of grade crossings. So it's able to map hundreds of these at the same time. And I wanted to kind of just, hopefully this will work, show just a quick video kind of how this works. Hopefully this is coming through okay. And
it's working.
Okay, so what you'll see there, the train is coming along, and as you can see, it's capturing whether on this one the arm position is down, whether the flasher is activated. Coming along to another one here. Again, it's identifying that what the position is correct. It is down, and if it identifies something isn't correct, then kind of that provides an alert. Now, the way that this system works is that when something is wrong, that will automatically create an alert, which is sent out to the the operating railroad, and they'll understand precisely where that is. They'll also have a copy of the video as well, so they can see that. Now, this kind of, I say, is more bang for your buck, but it is about condition monitoring. It's not necessarily about trespass. Now, the other thing that Wi-Tronix are looking at the moment, and again, there's something which the FRA have expressed a lot of interest in, and we're hoping that this is something that might get funded. But I'm going to show you an example of how AI can be used, not just at looking at the condition of infrastructure, but looking at the vehicles and people, which is one of the things that we really need to be kind of focused on. So this is another video, and as you can see here, it picks out vehicles and people as the train is going along. And yeah, pretty hairy example, actually not in the United States, but I mean, just I think to give you all kind of an idea of, that took many hours, many occasions of just machine learning just to get to that level. And we're at something like 92% accuracy of identifying if it's a car, if it's a vehicle, or if it's a person. The other factor to consider here is making sure we don't pick up the cars that are on the road, because they're quite right to be there, or even sometimes the right of way is quite narrow and there could be cars parked alongside here. You don't want to be picking those up. So machine learning is absolutely fundamental to this being effective. Okay, I have one other example, slightly different here. This is from our friends at the Michigan Tech that Jeff mentioned earlier. They're looking at kind of using drones, which again, audio-visual capture. It's not a static camera, it is mobile, but it also enables a lot of different kind of sites. I mean, such as that can identify if there's a chance of low clearance, if there is a chance of kind of beaching of vehicles, so they get stuck on the track. Also line of sight. It picks up where the trees or foliage is going to be in the way. It's going to stop the view of signals. And, kind of, again, some of the things that we've seen before. It can identify if the equipment is working properly, things like that. Now, drones, of course, are not like the train. They're not running there anyway with the forward-facing cameras. But this is a great kind of initiative for particularly problem areas or remote areas, particularly ones that maybe don't have many trains anyway. and probably not going to have many reports. So this will help spot an issue before it actually becomes one. Okay, so my last slide, and I probably spoke a little bit more than I should have there, but so technology, I think, is really an exciting tool, but it's not the solution on its own. It's not necessarily the remedy. All it can do is help build more information on the type of incidents that happen, when they happen, how often, and when. So those heat maps will enable a better targeting of the investments. So fences, sometimes audible alerts go in. So I know in Florida, the railroad has put in audible alerts when somebody walks over the railway line on particular high problem areas. There is an audible alert that comes out and says, leave this area, it's private property, you are trespassing, and kind of frightens the Jesus out of people. But you know, again, that's fine if you know if it's an area where the problem is. You need the heat map in the first place to know where those problems are. And there's other things as well. I mean, education and awareness campaigns. Many of you may have heard of Operation Lifesaver. That is a kind of a rail industry initiative in partnership with all of the states and the FRA to actually bring more education to dangers of the railroad, how to be safe. With over 100,000 miles of railroad across North America, clearly we have so many people whose lives and daily activity the railroad touches. And that's not just on grade crossings, that's beyond that as well. The design, Jeff mentioned earlier about kind of planning and not maybe putting a school on the other side of a railroad to where the houses are, just avoiding obvious planning issues, unless you can actually make grade separation. Grade separation means putting a bridge or a tunnel so that there isn't a need for an actual kind of grade crossing. And there is a huge program in the US. The FRA have got a large budget available for crossing closures. And that is great because they are expensive to do, but that's not necessarily the answer everywhere. For a lot of communities, losing their crossing could involve a significant kind of detour for journeys that they have regularly done. And how do you choose which one to cross? Do you look at the kind of the danger levels, or do you look at in terms of the community impact? So I think for states particularly, it's quite it's a beneficial process, and it's great to have the funding available, but also comes with other challenges as well. Okay, right. Last slide. I think I just wanted to conclude, and Jeff, kind of bring you in here as well, just to say, there's a lot of ways to actually address this. I think data will help, both historic and also the new data that we can bring in. But we have new challenges coming as well. Trains are getting faster. There is now going to be more passenger trains in the US with all the investments and the focus on kind of rail travel. Trains are getting quieter. New trains are electric as well, and also longer. The effect of all of those actually kind of has safety risks. Longer trains is a risk because it makes people act more risky at a crossing because they know they will be waiting longer. The other thing is, I mentioned earlier about, we've just talked about grade crossings. I mean, trespass on the rest of the railroad, the rest of the right of way, also remains a big issue. And I think, that is the next big frontier, just knowing where those hot heat map areas are, where we need to focus and put kind of remedial action and education. So Jeff, anything you kind of want to throw in before?
Adam Dory had a nice comment in the chat, which you can all click and read, but basically it was, encouraging the closing of crossings. And, working for the railroad, I'll just say that we would be delighted to close every crossing we possibly can. But as you might imagine, there is a lot of pushback from communities, even when they're a block or two apart. Each crossing is sacred to somebody in the community. Railroads do sometimes offer financial incentives to encourage railroads, like, let's say, for example, a community wants access granted to cross a railroad track somewhere for a new development, the railroad might say, all right, let's talk. I'd like to see you close 2 other crossings in the community. And then we'll put one in that's got good lights, gates, or something like that. As Andrew pointed out, there's an awful lot of money available right now relative to the past. There's still not enough to close a huge number of crossings, but there is more federal money available to do so, and many projects underway. I touched on Chicago Create in a talk earlier with this group, and there's some very notable grade separations going on there, where major roads, like a 6-lane highway that used to go across a highway rail crossing is now going through an underpass or something like that. So there is hope, but it won't come immediately. We would like to think that our network could be like the interstate highway system, where there's no traffic lights anywhere or crossings, but it won't be in our lifetimes, I'm afraid.
Yeah. Yes. I attended a conference earlier this year, the ASHTO, which is I won't even try, but it's the Association of State Highway and Transportation Officers, I think it is.
Yep.
Every year there is a one for all of the rail officers for all of the states in the US. And so the FRA speaker was actually promoting the use of was it $3 billion or something? I mean, it's an incredibly large amount for the grade separation. And one speaker, I think it was from Kansas State, talked about how it took 9 months for them to close one crossing, with 7 different community groups endlessly kind of going through in terms of what it is that they'll be doing. And that was to close one. Now, they could have actually done a grade separation project as well, but I think it kind of brought home, there's a lot of kind of effort required. It's not, it's probably not the right way to say this, but this isn't China. We kind of have rules around kind of due process, what we can do, which obviously is what we want. That makes a lot of sense, but it can kind of actually impact on safety sometimes. And in some ways, maybe the funds, if they're all in education, imagine if rail safety was part of the curriculum at elementary schools. Anybody within 5 miles of any kind of rail line, not just a grade crossing. I mean,
yeah, and that's something that, of course, Operation Lifesaver does a lot. They have a lot of tailored programs for school children, commercial drivers, etc. So one of the simplest ones is that there's a federal rule in the United States that every single crossing has to have a blue sign on it with a toll-free number to call if there's an emergency. And you'd be surprised the amount of the effort is put into educating the public, including the police departments, about this, and people still don't know what it is. They'll call up in a panic, there's a car stuck on the crossing. What should I do? Say, well, why don't you call the blue sign there, because that goes straight to the railroad. The policeman's just going to call the railroad if you call him, so call that sign first. So yeah, it's a good little thing just to mention this group right here. It's called the emergency notification number. Every crossing has one. It's a blue sign with white letters on it. It has a serial number for each crossing and a phone number. So don't hesitate to share that with your family and friends. It's a very simple, important thing.
Yeah, good point. I think, Jeff, we'll also send that out when send out kind of thank you and maybe a link to this presentation. We'll also put that out there. So yeah,
and Adam just mentioned that he looked at the Operation Lifesaver website. Yeah, and that's Operation Lifesaver is not just in the States. It began here, but it's in a number of countries around the world, including, I think, Poland of all places. So it's kind of interesting. Definitely, there's a lot of activity in Canada. And again, it's an education program. It's funded by the railroads. It's also funded by the government and others. And the whole idea is to educate people about the risks associated with crossings and what to do. If you're approaching a crossing in terms of, if there's a stuck vehicle or what have you.
Yes. Yeah. Okay. So, well, I know we're kind of coming down to the last 5 minutes. I'm just checking. I'm not sure we've got any additional questions in the chat.
Well, let me throw a plug to Wi-Tronix, and and since I don't work for them and Andrew does, I'll just mention that they're not they're a fairly new company, but they've come up with some very innovative things for the railroads. You know, for example, we have a term we call emergency brake application. This is where you manipulate the controls on the locomotive to stop the train as quickly as you can. It's something you do not do unless it's an emergency because of the forces that are built up on the train and all. But whenever that happens, it means there's something wrong. It could be that there's a child on the track or something, or it could be that the crew was not paying close attention and suddenly say, "Oh my gosh, there's a red signal," or what have you. But the Wi-Tronix has had a feature for years that whenever a train goes into emergency, a subscribing railroad will arrange for a message to be sent to somebody, some supervisor somewhere, like the what we call the road foreman of engines or something like that, so that they can reach out to the crew and ask what the heck's going on out there. It not only makes the crews a lot more alert that, wow, they're watching us, we got to be careful here and pay attention to what we're doing. Or if there's really a problem or something like that, the road knows about it right away. Like maybe there was a collision of a vehicle or something like that. So it's just one of the many features that the company offers the industry.
Well, I appreciate that, Jeff, and I guess I should say, anybody is interested in the kind of work that Wi-Tronix does, please get hold of me or any of the initiatives that are underway. A lot of them at research universities, all kind of fantastic work that's going on. And I can also, if people are interested in this, I can give you some links to some other kind of conferences where there's a lot of material. I mean, there's an initiative using thermal imaging to actually identify trespass on the line. I think that's at North Carolina State, one of the the university research arms. There's another kind of initiative underway at the moment, which is actually related, less to do with the rail. It's more to do with first responders and not having them stuck at grade crossings when they're responding to emergencies. And it's kind of actually, again, it's about data. It's picking up where grade crossings are likely to kind of be closed for the longest period of time, when emergency calls are going to be routed, and making sure that the dispatch for the fire, ambulance, and the police service kind of are avoiding that.
You use the term closed, Andrew. In this case, you mean blocked, I guess, for the more common vernacular. Not that the crossing is being removed from service. It's more like it's not available to the emergency response vehicles, so they can be sent a different direction to avoid it.
Yes, sorry, yes, the barriers are down. It can't cross. Yes. So imagine being on a line waiting for a barrier to open, and actually there's an emergency first responder there as well, also stuck in that line. I mean, that is quite harrowing to think that they're losing vital minutes. So
that technology is also being experimented with for the public, so that, for example, let's say there's a place where trains are blocking a very busy road during rush hour. There could be a notification sign at some intersection, not too far away from that location, saying train ahead, suggest alternate route or something like that, so people can turn and avoid it by going into a bridge over the tracks nearby or something like that.
Okay. All right. Well, so Jeff, I guess we kind of are now coming to the end. So what I'd just like to do is thank you for your time. And not just for this presentation, but I know this is a huge focus for the AAR, and all the people in the industry. Safety remains paramount importance to the railroad industry, and I think it's this kind of event is good to just bring awareness, not just to the kind of the safety issues, but also to the kind of mitigating actions that are taking place. So I'd like to also thank everybody that attended today. For those of you that aren't a member of the CILT, please investigate joining. We're not an expensive group. We have a lot of opportunities to do interesting things, and we always invite members to kind of be active on our various committees. We have boards on a regional level as well as obviously within North America. And you can contact me or take a look on our website if you're interested in exploring that further. And the last thing I would say, since we're on a railroad topic, so friend of CILT in the US is Jay Shabbat, who's the editor of Railroad Weekly. That is the kind of a trade magazine. It's primarily focused on the business side of the railroad industry in North America. Jay has kindly said that he's happy to kind of give a 3-month free subscription. Now, this is no strings. He won't force you to kind of put your credit card in or anything like that. Genuinely 3 months free to anyone that's kind of attended this event tonight. So if you're interested in Railroad Weekly, I think you can go on the website and have a look at one edition. If you'd like that for the next 12 weeks, then just drop me an email and I'll connect you with Jay to set that up. Okay, well, I think on that note, quite miraculously, we're actually going to finish on time. So I hope everybody found that interesting, and we'll share with you a link to the YouTube site where we're going to put this out there. Feel free to share it with anybody that you know that might actually also kind of enjoy what we spoke about this evening. So thank you all and good night.
Bye.